In this chapter, the axiomatic approach of probability, the main features of this chapter which we have studied about are as follows. Sample space, the set of all possible outcomes. Sample points, elements of sample space. Event, a subset of the sample space. Impossible event, the empty set. Sure event, the whole sample space. Complementary event or not event, the set A dash or S minus A. Event A or B, the set A union B. Event A and B, the set A intersection B. Event A and not B, the set A minus B. Mutually exclusive events. A and B are mutually exclusive if A intersection B is null set. Exhaustive and mutually exclusive events. Events E1, E2 up to En are mutually exclusive and exhaustive if E1 union E2 union up to En is equal to S and Ei intersection Ej is null set for all I not equals to j. Probability is number associated with sample point omega I such that probability of omega I is greater than equal to 0 and less than equal to 1. Number 2, summation of probability of omega I for all omega I belonging to S. Number 3, probability of A equals to summation of probability of omega I for all omega I belonging to A. The number probability of omega I is called probability of the outcome of omega I. Equally likely outcomes. All outcomes with equal probability. Probability of an event. For a finite sample space with equally likely outcomes, probability of an event PA is equal to number of elements of A divided by number of elements of S. If A and B are any two events, then probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Equivalently, it can be written as probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. If A and B are mutually exclusive, then probability of A or B is equal to probability of A plus probability of B. If A is any event, then probability of not A is equal to 1 minus probability of A. That's all. Surely you would have loved the chapter and mastered all the concepts.